Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is the variation of electron affinity across the period. Now, a quick recall. What is electron affinity? Electron affinity is the amount of energy released when an electron is added to the outermost shell of a isolated neutral gaseous atom to form a anion. Now, children, one example: if two students are there, out of these two students, one student accepts the challenge of board exam wholeheartedly. So that student will score more marks. And one more student who is not accepting the challenge of board exam wholeheartedly, definitely he'll score less marks. Here, accepting the challenge is nothing but accepting the electron, and the mark scored is nothing but amount of energy released, that is electron affinity. Right, children? Now, this electron affinity depends upon what factors? One is atomic radius, and another one is what, children? Nuclear charge. Now, how this atomic radius is related with electron affinity? Observe here, children. We have already discussed this. A quick recall. Now, we have two atoms. One is atom 1, right? And another one is atom 2. This is the nucleus, children. Nucleus which contains protons in it, right? Now, out of these two atoms, which one will accept the electrons readily? Obviously, the smaller atom. Because of the smaller distance, the force of attraction between the nucleus and the electron is more. So, it will accept the electrons most readily and it will release more energy. In this case, because of more distance, right, the force of attraction between the nucleus and the electron is what? Less. So, it will accept the electron less readily and it will release less energy. That is, conclusion from this one is smaller atom will accept the electron more readily when compared to bigger atom. So, the smaller atom is going to release more energy after accepting the electron when compared to the bigger atom. So, then what is this? What is the relationship? The relationship is something like this. Inverse relationship. What is this? As the atomic radius increases, this atom, right? So, the force of attraction between the nucleus and the electron is what? Less. So, it will not accept the electron most readily, then it will release less energy. That is, electron affinity is less. As the atomic radius decreases, that is this one, the force of attraction between the nucleus and this electron is what? More. So, it will accept the electron more readily and it will release more energy. That is, electron affinity is more, right? Now, children, one more factor. What is that? Nuclear charge. Sir, we all know that as the nuclear charge increases, so what will happen? So, the force of attraction, that is the force of attraction between the nucleus and the electron is more. So, it will pull with greater force, then it will accept the electron readily and it will release more energy. That is, nuclear charge is directly like nuclear charge and electron affinity is having a direct relationship. That is, as the nuclear charge increases, the amount of energy released, that is, the electron affinity is more, right? Now, children, to understand this variation of electron affinity across the period, we'll consider the elements of period 2, that is, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and what? Neon. And their configurations we know it is 21, 22, 23, 24, 25, 26, 27, and 28. Now, children, we all know that what is going to happen to the atomic radius across the period? Obviously, it is going to wait. Let me demonstrate this. Children, this is the nucleus and this is the outermost shell containing electrons. So, this is the first atom in the period 2, right? Which one is that? Lithium, right? Now, beryllium. Observe here, this is lithium, beryllium, smaller than lithium. Then, boron, still smaller. Then carbon, nitrogen, oxygen, fluorine. Observe neon, bigger. Now, conclusion from this one is across the period, the atomic radius is going to what? Decrease. Now, which is the biggest atom? Lithium. Which is the smallest atom? Fluorine. Now, as the atomic radius decreases across the period, then the electron affinity should, what children? Increase. Now, in the same way, what is happening to the nuclear charge across the period? Sir, lithium has got 3 protons and fluorine has got 9 protons. So, nuclear charge also increasing. So, as the nuclear charge increases, the electron affinity values are going to what? Increase. So, overall, based on the 2 factors, right, which element is having a lowest electron affinity in period 2 will be which one children? Lithium. Why? Because that is the biggest atom with the less nuclear charge. And which element is having a maximum electron affinity in period 2? It is fluorine, which is smallest and it is having a maximum nuclear charge. Now children, to understand this variation of electron affinity better, we'll consider the values. Now I am writing the values only to make you understand. No need to remember the values for the board exam. Now children, electron affinity values, right? The units generally it is kilojoule per mole, or we can also express in electron volts also. Okay, observe the values very carefully children. Now lithium is something like this. It is in electron volts children, minus 0.61. So for beryllium it is Exe, exception. So boron 0.62 and carbon is minus 1.25 and nitrogen is Exe, oxygen is minus 1.48 and fluorine is minus 3.60 and for neon it is 0. What is the 0? Children, we'll discuss this later. And also we'll discuss about this beryllium and nitrogen, why it is Exe, that is exception, in the coming videos. Now children, sir, why this electron affinity is negative here? Obviously, exothermic reaction is the one which proceeds with the liberation of what? Energy. So energy is given out, that's why it is what? Negative. If it is absorbed, then it is what? Positive. Children, electron affinity values, always it is not negative. There are cases where the electron affinity values, that is, are positive also, right? So that you are going to study in your higher classes. Now, come to this one. When lithium accepts electron, the energy released is 0.61 volts, electron volts. When the same fluorine atom accepts the electron, it is going to release minus 3.60 volts, right? So conclusion from this one, see, if you are not considering the signs, only the values, 0.61 is more or 3.60 is more. Obviously, 3.60 is more. So conclusion from this one is, across the period, the electron affinity values are going to increase. That is, the amount of energy released is going to increase because of decrease in what children? Atomic radius, and increase in what? Nuclear charge. So this is the conclusion about across the period. So across the period, electron affinity values are going to increase. The element with lowest electron affinity will be lithium and the element with highest electron affinity will be fluorine in period what children? 2. Now coming to the next one. So why this neon's electronic configuration, like electron affinity is 0? What is 0? Why it is 0? Was we all know that the electronic configuration of neon is 2,8. In higher level, we write the configuration something like this: 1s2, 2s2 and what's 2p6. So what you say is that neon is already having a what? Stable structure. What is that stable configuration? That is octet structure. Once this atom is stable, right? So stable in the sense, now observe here. Fluorine has got how many electrons in the outermost shell? 7. So after accepting one electron, then it will become stable. That is, F minus configuration is 2, 8. So that's why fluorine atom, which is having 7 electron, is accepting 1 electron. But this neon, it is already having how many electrons in the outermost shell? 8 electrons. That is nothing but 2s and 2p orbitals are completely filled. Then why it will accept the electron again? So because it is not ready to accept the electron affinity values of noble gases or neon is nothing but what, children? 0, something like this. So this is the variation of electron affinity across the period. Why neon is not accepting the electron? Because it is having a stable electronic configuration. That is, it is having a octet configuration. Okay, children, I hope you have understood whatever I have discussed today. We'll continue the remaining in the next video. Thank you, children. Namaste, everybody.